This is going to be an overview of our most recent lessons in the unit. We're going to start with Lesson 7. In Lesson 7, you looked at different setups where you mimicked different environments inside of a sealed 2-liter bottle. And these different environments, some had liquid water at the bottom, and we were measuring the humidity in each one, so it had a percentage. And we found out that water gets in the air from evaporation. So what happens is we have a light source, either the lamp or the sun, and we know that energy is being absorbed by the water, and that the water molecules increase energy, they get warmer, they're able to move more, and then become a gas that can go into the air, and that's how water vapor gets into the air. In Lesson 8, you looked at a series of videos that zoomed in on the behavior of water molecules, and this was represented by the magnetic marbles. And we saw that when the marbles move slow enough, they are attracted to each other and clump up. And that when they have more energy, they are able to break away from each other and move apart, or can move past each other without clumping. And the same thing was true for water molecules. If they slow down, they like to clump up. That's how you could see the water pooling over the penny, and that is how water droplets form. The water molecules in the air slow down enough that they end up clumping and sticking together. In Lesson 9, we learned about CCNs, cloud condensation nuclei. These are the tiny particles of dust or pollen in the air that allows water molecules to clump. And then when enough of the water molecules form, that's how we see clouds. This was demonstrated in a demonstration with the ice pack. And so you saw that ice crystals were able to form on, or frost was able to form on that ice pack, because the surface of the ice pack acted as a CCN, allowing the water that had evaporated to condense and collect on that ice pack. Lesson 10, you created a model looking at how storms developed. You should have included how temperature is involved in the formation of these really large cumulonimbus clouds, the humidity level, which plays a large role. You should have added in CCNs. And with temperature, you wanted to make sure that you had included the temperature higher up and down on the ground, because that temperature difference plays a big role. You could have also added in that evaporation is needed, so water has to move from the ground to the air, and that would happen as liquid to gas. You could also include density, which when there's air that is less dense, it rises. So less dense rises, and that's how you get those really big billowing clouds. In lesson 11, you looked at a video demonstration that talked about the force of air compared to the force of gravity. So we had a straw, and the force of air was pushing up, and you also had an object like a ping pong ball or tissue, and the force of gravity is pulling down. Now, when that object moves upward, we know that gravity is weaker than the upward force of air. So if it moves up, that means the air is greater than gravity, the force of the air moving up. If the object moves down, we know that gravity, the force of gravity, is going to be greater than the force of air. And if there's no motion, so that object appears to be floating in the air, it's neither falling nor rising, we know that the force of gravity is equal to the upward force of the air. And the same happens in clouds. So that water, the hail that is in the cloud, would be lifted up by air and could stay suspended as long as the force of gravity is equal to the force of the air moving upwards. And it won't fall down until the force of gravity is greater than the upward force of the air. Finally, most recently, in lesson 12, we were looking at how and why that temperature difference plays a role in the movement of clouds. So in one of the experiments, you saw that there was a really big difference in temperature. This saw lots of movement. So you could see a lot of the food dye rising as it was heated by the very, very hot water underneath. You could also get lots of movement if there's a large amount of substances involved. So, for instance, when in the second experiment there was more of this hot water, there's more energy that can be transferred to the dye, and more dye that moves upward more quickly. As you move on to lesson 13, this is going to take everything we've learned in the whole unit to help us explain our big question for why some areas experience more hail than others. As you're making your model, it's very important that you use this rubric as you develop your Gotta Have It checklist to make sure you have everything you need to include. You need to make sure that you explain what is happening to water in this instance of hail forming. What is the energy source that is causing this to happen? Explain how clouds form and what type of cloud is involved. How is hail forming in this situation? How is air moving, and what role is it playing in the development of these hailstorms? How is temperature involved? Where does the temperature difference matter? And wind, or the force of air, how is this playing a role in forming the hail? Make sure that you also make unseen processes visible. So we would want to see what's happening with convection. When is conduction being involved? I would go back to past lessons and review. This is two different types of heat transfer. This is through touching, so through contact, and this is convection is all about fluids. And then you also need to zoom in on the water molecules, showing the role that density is playing with different temperatures. Some other things that you will have to show would be the temperature difference between the ground and air causing the change in density, how a change in density is causing updrafts and what updrafts are, and that the transfer of energy in the air causes the updraft to stop. You would also need to be sure to include some basics to help make your model easy to understand, such as labels, and including all essential vocabulary that we've learned in this unit. All the vocabulary words you need to use in your model are listed right here. And finally, you need arrows, and this will show energy and movement of matter. Make sure you are going back and using this rubric when you are working on your model, whether you're working alone or with a partner.